So this is a high-level overview of the InterPlanetary File System. So my name is Yiannis. I am working at Protocol Labs, in particular the Protocol Labs research, and more in particular in a new lab which is called ResNetLab, and is investigating things related to resilient networks. So trying to do research that is going to support the projects in an effort to make networks more resilient. So IPFS is not a single project. It's composed and taking components of several different ones of them. And just to mention a few is libp2p, which is the networking stack, IPLD, which is more closer to the naming formats, multi-formats cluster, and many others. So the first thing that someone has to say when talking about IPFS is that it is trying to make, to transform the HTTP and the client-server model that we have today in a peer-to-peer network. So make the web like peer-to-peer. And as most of you know, there have been many different architectures proposed in the past to do peer-to-peer networking. These have, IPFS is borrowing lots of ideas from those past versions of architectures, but it's also trying to enhance them and make them and take a step further. This is in several different ways, and one central one of them is that IPFS is a central part in Protocol Labs in general, is to move from a centralized model to decentralized and eventually distributed mode of communication. This was not necessarily the case back when other peer-to-peer architectures have been proposed, and we're increasingly seeing a momentum towards decentralization of internet services that was not there 10 years ago, but is very, very prominent today. So as a summary, we can have, we had the Web 1 model which was about static content, then the Web 2 model, which is what we have today, and is talking about interactive applications, and then this has resulted in many applications being controlled and monetized by several different tech companies. What we want the Web 3 to look like is similar to Web 2, but with an extra element, which is this element of trust. So removing trust from the equation and having networks that are more autonomous and without relying on centralized authorities is something that is very much desirable. And yeah, some of the problems of the current web is that it can be censored. We have seen many different governments in several parts of the world censoring and even cutting the traffic around the networks. This group, I'm pretty sure, knows very well about the inefficiency when we're transmitting content, and when we have several different requests for the same piece of content, we don't want, it's totally inefficient to have several different copies of it being transmitted. Also, the current model does not allow for offline use, and this is something, again, that is hugely inefficient. And IPFS is is not necessarily solving all these problems, but it's attempting to build a network stack that will allow others to build applications on top and overcome those problems. A central part in doing all that is, so yeah, why distributed? Is distributed because we can overcome all those problems, become more efficient, more resilient, offline first, and yeah, last but not least, have less trust into several different organizations. So a central point in the vision of IPFS is that, and the ecosystem around it, is that we need to move from a location-based model to a content addressable model. So instead of having some URL like example.com, instead we can have some address of the content itself, and therefore, as I'm pretty sure this group knows very well, we don't necessarily need to travel to faraway servers to get some content when this content could be located near us. So, as I said, there are many different components that enable and compose the IPFS stack. One of them is libp2p, which is basically the peer-to-peer network layer stack. And it takes care of peer routing and peer and content routing. There is the IPLD, which stands for Interplanetary Linked Data, and is the data layer of the stack, is how things are named and how things are linked between different objects. And there is the multi-formats project, which is also providing some formatting structure and formatting rules, basically, that connect and take things from the IPLD space and connect them to libp2p to the network, basically, to connect different peers in the network. So some key facts about IPFS is that all content is authenticated without having any central server. So all peers are pretty much equal in the network. There is content is never pushed into users' devices. Instead, there is more kind of pool-based model where when a peer is requesting something, this is fetched, and only then it is cached on the device of the user or the end host. And content, of course, can be anything. It can be not only large data files, but it can be web, it can be blockchains, it could be arbitrary data sets, and so on and so forth. So what we're going to see today is the life cycle of IPFS, from adding files to getting files. And when adding files to IPFS, there is this quite common screen that you see when you're using different tools as well. And as part of that, you see this long list of numbers and letters, which is the CID, the content ID. So this is what the user is adding into the network. And it's worth noting that when someone is starting to use IPFS and you're adding a file to the network, we should keep in mind that when we're adding a file to the network, this is not going out of our computer. It stays there, and what is going out to the network is this the provider record for this CID, saying that this is the machine that is actually storing this content. Instead, when getting files, similarly, we need to have a similar command which says IPFS get, and you're getting this. If putting this CID means that you're going to get this content back. So if we want to have a look and see what happens in between adding a file and getting a file, we need to import the data into the network, we need to name it, and then on the other side, we need to find it and fetch it. So in a sense, the first two parts is about a content publisher or a content producer that wants to publish something into the network and let the world know that this is something now available to others. And on the right-hand side, the find and fetch is the content consumer, which is when someone else has taken, knows the CID of what they're looking for, and they want to fetch some content. So there are different steps, and we're going to go through all of them, from import to naming, finding, and fetching. And to give an overview of the projects and where they roughly fall into, we see the IPLD is falling into this side of things, so importing and naming things. And the libp2p is on this side of things when we want to do peer and content routing. The last one, multi-formats, is kind of linking between the two, as we're going to see, providing different rules to format naming structures. So chunking, the first thing that is happening is that when someone has got a file, needs to chunk it into different pieces. And this is done for three reasons. It's basically for deduplication, or this means basically if you have the same part of the file two times, or the same file two times within a folder, then what we call, in another way, I call more often redundancy, is that you don't need to transmit this piece, the orange piece here, twice. What you can do is basically deduplicate and transmit only the pieces that you want. Then it's piecewise transfer, which means that you need you get chunks of the file, and similar to what NDN does, of course, is that for a chunk of the file you can check if what you received is correct or not, and if you didn't receive it correctly for some reason because it was corrupted, when seeking back and when asking for the remaining part, you can ask for that only and not for the whole file. Yeah, so now we're going into something that is commonly called UnitsFS in the IPFS ecosystem, and IPFS by default is a file system. So similar to what we have in a file system, we have files, but we also have folders. And what you have in folders, a folder basically what it is a different type of file, right? So similarly to CID that you have within for a single file, what you have is you can have a different CID for a different folder. And what you end up with is that you have a root CID that is containing all the contents of the folder. In our case, and in the example that we had in the previous slide, these can be different chunks of the same file where you have a root CID, but then you can have different CIDs for each of the pieces that you have within the file. And this is how IPLD is approaching content addressing. Now, with this, what this forms is what is called Merkle DAG, the Merkle Direct Acyclic Graphs, which is basically a data structure where each node here has got its content addressed and has got its own CID. So you have a content identifier for each one of the chunks that you have in a file, and then what you have is the root CID, which is the root CID of the whole file. Once something changes within any part of the tree, then the root CID is going to be different as well as the CID of the particular node. This is used in the IPFS ecosystem, and in particular by IPLD, to realize basically the transition from location-based identifiers to content-based identifiers. So we see down here that basically what the equivalent of an HTTP request would look like would be IPFS : / and then you would have the CID. Now, the interesting thing, which IPLD, which I think I mentioned stands for Interplanetary Linked Data, is what is called the Merkle forest. So given that each one of the pieces or chunks within an IPLD node, so the node is a graph of the Merkle DAG, of the Merkle tree, each one of those pieces has got its own CID, then this, with IPLD powered language, this means that any part of this can be used anywhere else. So you can have, you don't need to get some part of it, this transaction or this asset or any document that is within this node, and copy it elsewhere. It can just be used as it is in the current location. You just need to add a pointer to that to what you're looking to address, basically. So here, for example, if we have an author that has got some asset and has done some payment, then these can be used. Then these payments, if it's a transaction message, say, it can be used directly, exactly as it is, by a totally different structure, such as a blockchain. Right? And that's why it's called the Merkle forest, because you can link from one tree to the other. Any questions up until now?
We got some questions in terms of like chunk size and types of chunkers. I've been trying to fill in the details as you present, but I don't know if you want to bring it up. So the question is there a chunk size by default, and can people like use different chunk sizes, and what are the caveats with that?
So, sorry.
Those are the details. I'm more interested in how this tree got created.
Right. So this tree is getting created by every time, basically, if you think of this in a simplistic way, every time, say, you have a file, before you add it to the IPFS network, you have to chunk it. And by chunking that, every chunk is getting its own CID. Right?
Yeah. And but fundamentally, how a file is added into the system. That's a more interesting question.
Sorry, can you repeat?
How to add a file into the system would be a more interesting question, because I suppose that there's an unlimited number of users who may add the files into the system.
Yes, exactly. Yeah, they are. So these different, the different chunks of the file could be, the different parts of the tree could be different chunks of the same file. It could be different versions of a version document, just like Git or similar things like that. So you can, by adding, if you want to be, if you have a document file or whatever on your machine, then you can add it to the network and add, and what you're doing effectively is that you're adding a pointer to the network, and you're letting the world know that this particular CID or this particular file lives on this machine, on your machine when you're adding that. Is that answering the question or not?
Let's just get to a different question. That is, how do you let the world know about the binding between what you added versus where you call the location?
Right, so for this you have a provider record, and the provider is basically the machine, the IP address of the machine where you're hosting the file, and then you're distributing that to the DHT that we're going to, is through a distributed hash table that you're finding a peer which is closer to the hash of what you have created, and you're adding to the network, and they provide the record for this file to point back to your machine.
But the DHT already assumed that I know what to hash. So you can hash into a DHT system to find that piece. The question is that, how do I know what new files get added into the system?
Right, okay. So I see now what you mean. So how do you know as a user what others are adding into the system?
That's right.
Okay, right, okay, fine. So this is something that I'm not covering in this presentation. It goes more into kind of a decentralized search engine, if I can put it this way, where, so in order to become aware of a CID, this has to happen off-band, basically. Someone needs to let you know that this is the content identifier of the file that you need, that you want. So it's kind of external into the system. There is a very interesting kind of line of work towards there that says, how can we search for content that lives within the IPFS ecosystem, in the IPFS system. But as far as I'm aware, there isn't anything in working order.
So I don't know if you are familiar with mobility first.
Yeah.
This sounds very much like a mobility first basic approach. That is, how you find the contents is external to the system. Just once you have the some identifier unique, then we can retrieve that piece for you.
Yeah, exactly. Yeah.
Okay.
Yeah. Okay. Any other questions before?
Yeah, I have a question. So
Yeah.
for user, in order to retrieve, for example, this currently this Merkle graph that represents a file with different pieces. For user to retrieve this entire file, I need to have this entire tree structure so that I know which piece to retrieve. Is that right? So it's not enough just to have the root CID. I have to know the internal links of this structure. Is that right?
Right. No, actually, in this case, if you have the root CID, you then can have the rest of the tree. What is happening is the problem is actually the opposite. So if you just want these payments, the way that it is kind of currently implemented is that it needs, you would need to get the whole file before you can link to that. And this is inefficient because you need to spend much more resources and much more bandwidth in order to get to what you want. So this is a similar problem that we have seen in other areas as well, where, you know, if you have, say, the root CID of a zipped folder, it's very unlikely that you will want just part of it. You just either want all of it or none of it. But if you go to a YouTube video or some video kind of thing where you don't, if the video is, you know, imagine a whole conference taking place 5 hours and you're just interested in, you know, a 20-minute talk from someone in the middle of it, then getting the root CID only and having to stream and download the whole 5-hour thing before you can get to where you want is problematic. And therefore, there is some discussion that this needs to change in order to make it more flexible. But if you have the root CID actually, then you can get the whole file.
Mm-hmm.
The open problem that that we're looking for is the opposite.
I see.
Mm-hmm. Okay. Other questions? I see something blinking on the corner.
Question, once a block is assigned a CID, is that block immutable?
Right, yes. So once a block is assigned a CID, this block is immutable. And, you know, if you change anything in this block, then you're going to change the CID as well. So you're going to be looking at a different thing. So this is a good property because it can make sure that, you know, when you're retrieving something and you're getting some bytes from the network, you can then, having the CID beforehand, you can check that the content is actually what you requested from, what you requested for, because you can calculate the CID that comes out of the bytes you received, and you can compare it to what you have. And if it's the same, then you know you got what you asked for. On the flip side, though, what you don't have is that it's difficult in this particular case to update content. So if you have a document or any piece of data, if you want to do the slice test change to it, then you are going to create a new CID for that, which you need to publish to the network. And this makes it difficult for the wall to know an updated CID every time you try to change something. This, though, brings to the next slide, I think. No, we're going to address that in a little bit after a few more slides.
I have one last question about the content, the CID.
Yeah.
The CID is like a checksum, for example, a hash, because to guarantee the integrity of the block. Is that?
I missed you for a moment. So yes, the CID is the hash of the content, and then I missed the rest.
Okay.
To
Two more questions. Yeah, go ahead.
The CID doubles both as a hash of sorts and as the address of the block. So you can both verify that the block you got is correct by checking it against the CID, making a calculation locally, and you can use a CID to ask the network who has this.
Exactly. Yes, exactly. Yeah.
So two more questions, Yiannis.
Yeah.
One is about revoking a CID. And the other question is how to tell that there is a new version that has been created of a given object.
Right. So let me start from the second question. So the updated version is what this IPNS here is taken care of, and it's called the Interplanetary Naming System. I'm going to get into that after a few slides. Removing a document from the network, I believe it is possible. Yeah, I believe it should be possible. Yeah.
Maybe I can fill in that detail. So as Peter brought up, like a CID is not a sign, it's derived. So it's just a CID is just like the hash of a content plus some information about which hash function got used and like what is the type of the content. Yeah. So it never gets assigned. For revoking, as in like making sure that something cannot be resolved on a network, we have like simple block lists. So you can enumerate CIDs that you don't want users to resolve through a gateway or through their local nodes. And as long as users respect those lists, they will not resolve those CIDs.
Right, and also the CIDs expire as well. So is that I think that's
Well, that's a question. There's got two questions now. Why is you say CID expires? Where is the lifetime?
The provider record is expiring. Sorry, that's incorrect.
But does that get removed from the DHT?
Eventually, if all the providers of specific CID do not carry on providing them this particular content, then this eventually is not going to be found in the DHT.
But there's really no check to see whether something gets removed per se.
No, as far as I know. No.
The second question is the earlier thing about there's a separate list of what CID got deleted. So that sounds like it's outside the main system, but another piece, like a revocation list by the certificate, right?
I'm not sure I got the question.
I think there's someone, I think David answered the question maybe, to say that there's a separate revocation list.
That's correct.
Yes.
So that has nothing to do with the DHT per se. That's an entirely separate data structure.
Yes, that's correct. So so as like Yiannis brought up in the beginning, like IPFS doesn't force anything on the users of the protocol. Mm-hmm. So in the same way that like you cannot force someone to store a piece of data for you unless they actually proactively ask for it. Mm-hmm. IPFS also does not provide the capability of purging content.
Yeah.
And so
my question is really a separate one. Because the DHT, everyone knows there's a peer-to-peer system, mm-hmm. but it's a separate data structure. Who maintains it?
Depends on which network of IPFS you're talking about. For the main network, so the one that is like publicly live, that nodes bootstrap by default, currently Protocol Labs maintains that list, and that list can be consulted through our gateways. But you could run your own IPFS network and maintain your own list if you wanted to.
So this
and
is
moreover,
just
fill one more detail. A node can, and some nodes do, entirely ignore such lists. So this is part of the censorship resistance in a way. The blacklist is maintained for for legal reasons and and to keep the network healthy as a whole. But each individual actor can very much elect to ignore this list and advertise having CIDs that are supposedly illegal, for example.
Yeah, I think there's a separate issue that is, whether it's needed or who runs it. My question more on the design side, that this piece is not distributed per se, like a DHT.
It is not. So right now it is a moderated list. We could make it distributed using IPFS, which Yiannis is going to bring it up, but currently it is just like a list that exists on previous known locations. That's correct.
Okay, thank you.
No problem.
Okay, so shall I carry on?
I think we have two more questions. So about one is, once something is removed, is there a Merkle tree reconstruction needed? And how often can that happen? And then second question is, does the mainnet DHT route the request for a CID independent of the blacklist?
Right, so once something is removed, then in order, the Merkle tree cannot, this part of the Merkle tree cannot be constructed without this piece being back. The CID, there is a placeholder for the CID, but you need to be able to resolve that to the specific content if you want to retrieve the whole content. I don't know if this answers the question. And then the second one is, can you repeat the bit?
Yeah, of course. Does the mainnet DHT route the request for a CID independent of the blacklist?
Yes. Yeah, so there is no, if I'm getting it right, so a node before forwarding a request is not checking any blacklist or anything, right?
Yeah, so if you run a node locally on your machine, and if you try to resolve a CID through your local gateway, right? So this is like something running on your machine that you control, that you own, that you make decisions. It will not take blacklists by default. Yeah. If you use one of the multiple gateways, so this could be the one that Protocol Labs runs, could be Cloudflare, could be Infura. If you use one of those nodes will check the blacklist first and then decide to resolve it or not.
All right, okay, I didn't know this detail. Okay, so the gateway does it. Okay.
Yeah, right. Exactly.
Yeah. But okay, fine.
And so it puts the responsibility on the user, right? So if a user decides to resolve some piece of content that has been blocked for some reason, and that reason can be many, right, as we know, the user gets to decide to comply with that reason or to decide to resolve the content anyway.
Yeah, cool. Okay, so, okay, should I carry on?
Yeah, go ahead. There's no more questions right now.
Okay. All right. So, okay, lots of what we discussed about IPLD and all the content identifiers depend on the CID, which, by now it's clear that we're talking about content addressing, it's self-describing, and it's basically a hash with a bunch of metadata that we're going to look through now. Some properties of the CID is that it's verifiable, it's immutable, as we mentioned, it's trustless, and it's permanent, meaning, as we just mentioned, that the CID is going to stay and is going to point to the object that when it was created. It doesn't mean that this object is always going to be there. Nodes are cached, something might disappear from the network, and therefore the content might not be there, but the CID is going to remain the same, for this particular object. So what they look like is something like that, where you have a multi-hash, a multi-codec, the CID version, and a base. And this is, we're now getting into this multi-format, which is self-describing rules for naming data. And we're going to see a couple of examples for each one of them. So a multi codec is basically something that uniquely, a number that uniquely identifies a protocol or a concept or something that you want to add into the network. Then you have the multi-hash, which is the hash digest with some extra information, and the multi-base, which is the base encoding string. So the multi-codec looks something like that. You can have representations for IPv4 for different network protocols, transport protocols. You can say you can put the name of something new, identity. Most commonly, so there is a big table which is publicly available for that, and a big part of that could be hash function, which is used for the multi-hash. So the multi-hash going into the next step is the hash digest, the hash, the length of this hash digest, and the hash function that someone has used in order to produce the hash digest. And this needs to be known by both sides, and therefore needs to be inside the name. It gives the very nice property of, if you want to change the hash function of something that you're using, all you need to do is change basically these parts, and it's kind of what it's called future proofing, because it can be updated at any time. Finally, the multi-base is basically the prefix of the base that you're using for encoding data, and this goes in the beginning of the CID. So the CIDs, there was an initial version, the CID version 0, which was only the multi-hash, and then the CID version 1 added all those different bits into the CID structure, and that was needed because you want to link between different Merkle trees, as we said before. And in the example that we mentioned before, for example, in a few slides back, you can have the block of a Bitcoin block, or the transaction, which was the payment that we mentioned back there. And this can be the same as the one used in the actual blockchain, and a copy that a user wants to have, which is outside the blockchain. These, you can jump back and forth from different structures and have the same name for the content itself. CIDs use paths as well. So you have something like that, which goes into the multi-address space, which we're going to look at in a bit. And what you want to have is different parts and different protocols as part of the path that you want to use. So an IPFS name is going to look like IPFS, then the multi-format that we mentioned before, and then whatever the file name is. Now, finally, what we said before is about IPNS, the Interplanetary Naming System, and this is something that is adding into the whole system is mutability. So as someone mentioned before, if you have a content and you update it, then you get a different CID, and this is not very practical for applications. So what you want to have is being able to provide one kind of CID or one identifier, and then being able to change but use the same. So what IPNS does is that it points basically to public keys. So when you publish something, you can publish it on IPNS and give the public key of the content that you're publishing. The resulting content is signed, obviously, with your private key and has got the CID that we saw before. And then when you want to change that and update your website or a document or whatever it's going to be, you can do that because users are still going to get the latest version because your public key has not changed. And that's a very handy way of doing that. So any questions for this second part before we get into the third one?
Nothing in chat, but maybe someone has one. Oh, doesn't seem like it. Oh, wait. How long does an IPNS record live?
How long does an IPNS record live? I don't know if there's any TTL value that needs to be updated. So, yeah, I don't know that. I think, yeah, I don't know.
You would need to check. Like the numbers I have in my head is either 12 hours or 24 hours. It's one of the two. But like this is also adjustable, right? So this is just the default.
Yeah. Yeah. Okay. Yeah.
That blanked out momentarily. Where was this IPNS record kept?
So where is the IPNS record? So these are kept in. There are some nodes that are they're called bootstrappers as well, that are used for keeping IPNS records, right?
What those bootstrappers? Who maintain them?
So anyone. Sorry?
The IPNS relies on the same content routing as like the provider records, so you can use the DHT for putting them, right? So you use the DHT to find the nodes in the network that are storing these IPNS records. It's the same technique. Additionally, what we have built as well to make sure that updates can propagate fast is using PubSub. So you can create a PubSub topic, and then nodes that are interested on really fast updates for those names, for those pointers, can subscribe to that topic and get the updates faster rather than having to crawl in the DHT every time. Additionally, if you wanted to have a specific node in the network that would take a higher responsibility of like just storing the records for, let's say, your domain, your system, your enterprise network, you could also do that. That there is also modules available.
That would be outside of the DHT system.
So as I said, like the default is DHT. Then
you mentioned later, you say that if you want to have a fast lookup, you can have a separate server.
Yeah, exactly. So the third option,
that separate server is outside the DHT.
Yeah,
okay.
That's correct.
So DHT is other than the hash randomly, so that you cannot know when the next hop. Otherwise, it's a pretty smart system. The problem is that you have to know exactly what you are looking, so you can do the hash. And the chicken and egg thing. You want to know what's out there. You don't know the exact name, then you cannot use DHT. That's what I see as an issue. There seems some magic I'm trying to figure out.
So that's a great question. And essentially, the trick that we use is inspired by the self-certified file system, SFS. And rather than putting pointers on the network that use, so comparing to the CIDs, which are immutable records, the way that we do mutable records is instead of like using them or putting them on the DHT by the piece of content that they point to, we put them on the DHT by the CID of the public key that is being used. So this CID of the public key is going to be immutable, right? Because it's going to be always the same public key. So you as a user can subscribe to updates from this IPNS record that references a public key, and you are guaranteed to always find the most up-to-date records as long as there's someone publishing them. So this is where it's the difference between having to know what are the CID of the content that we are looking for and just following a name that always is the same name. Therefore, I can always find the most up-to-date record of that name. I hope it's clarified.
If you put the name into the DHT, but the name can point to different things, that seems to open the can of issues. You know, if things can be changed, it can be changed in many different ways, by good guys, by bad guys, and
well, yeah, that's a great point. And then so one of the assumptions I'm making here when I say, oh, it's the CID of the public key. So we use this like self-certified file system trick where every time you publish the record, like the IPNS record, you are assigning that record with the private key. And so for the people following that record, they will validate the signature and check that like the author of the update to that pointer, to that name, is actually one of the nodes that was either a previous publisher or some trusted node. And what this means is like only the holders of that private key can actually change the pointer. So it's not like everyone in the network. Otherwise, it would be like a security risk, as you highlighted.
Okay, thank you.
No problem. Yannis, you have one more question here. I'm still reading it. So if the publisher of the IPNS record goes offline, then the records in DHT expire and then IPNS stops working, right? This means that IPNS links have the risk of being broken within a day unless the original publisher stays online. You won't even get an old record.
Yeah, that's correct. Yeah. So the records need to be updated in order to know who is hosting which content. So yeah, that's correct.
There is no more questions, Yannis, if you want to continue.
Okay, fine. So so that was largely the part where we talked about the content producer, the content publisher, and there is the second part, which is basically the content consumer, and this is dealt with by libp2p, which is a modular peer-to-peer networking stack. And it can be used, it's worth noting that it can be used independently of IPFS. It doesn't, it's a library that can live on its own, and it can serve several different purposes. For the purpose of IPFS, what libp2p is doing is that it's getting a content address and translating that to a location address where you then need to go and fetch the content. So libp2p is a decentralized, enables decentralized process addressing, and it can interact and locate and connect to any process in the world. But yeah, as long as there is an identity that is signed on the other side of the link where you want to connect to. Now, this is very interesting because it can be the same, and libp2p can provide connections even as those processes move. So there could be some kind of mobility, or when you take your machine and go to another network, and still you're going to be able to connect as before. There are several different parts that make up libp2p. So there are different transport protocols. There is PubSub protocol that David mentioned before for IPNS and for other purposes. There are NAT traversal techniques, but most importantly, at least for this discussion, is there is peer routing and content routing. Now, libp2p is the basic, the basic component that operates the distributed hash table within the IPFS ecosystem. So this is an example linking again to, I mean, it's just one example of what libp2p is doing, but it links well with what we discussed before, which is the multi-format and all those different parts of a name, which is the multi-addresses. And here is an example where you can see that someone is connected through IPv4 to this IP address, through this transport protocol, and through to this port. and requesting some ID XYZ. So in terms of routing, so the peer, there are different types of peers. There is on the DHT. I mean, okay, entering the IPFS ecosystem, you become a peer in the network, and then you join the DHT. So the DHT someone can join as a server or as a client. There are several, every peer needs to have an ID of its own, which is the cryptographic key pair, basically, by which it is identified. And this is used in any DHT. You need to be routable in order to be reached by outside nodes, which presents, of course, problems when we're living in the world of today and we're behind NATs, which makes it difficult to get and to connect and get content from some peer in the network. So the DHT itself, okay, I've got several slides, but I'm just going to go through the most important material. Is a key value store, as we know, and it's used for content discovery and for peer routing. So when you want to have, so here's an example down here of an IPFS DHT table, which you can have the key, which is a CID, and it can point to another CID, or it can point to an IP address, or to another node, the relay in the network, or anything similar. Now, okay, the academia, I've got some slides, but I think, especially given all the questions that we had, I don't think it makes sense to go through all of them. The important part to mention is that the academia DHT is using the XOR distance between two pointers. It initiates several parallel asynchronous queries, and it uses a tree-based routing. Now, what this means is that if we have this node, for example, it would have different subtrees in the K buckets of its routing table, and that's where it's going to start initiating connections in order to try and find some content. So, for example, if you want to go from node 0011 to another node 1110, which is down here, then this node is going to start parallel connections to different parts of the subtree by breaking the hash space into different parts in order to basically jump big parts and go far away in the DHT to make it more efficient to get to the node that is looking for faster. The parallel connections is done because you don't want to basically wait for some node to respond when this node might just be offline, and therefore you have to wait for the whole of that timeout value.
You got a question?
Sorry, yeah.
So it's still on the naming part. How can other nodes tell that they have the right public key for a name?
The right public key for a CID name, I guess. So this again has to be done offline. I mean, it's outside the IPFS system, right? So it's the same as you need to be provided that.
It's not so much provided. I mean, yeah, you provide, but the binding still need to exist, right? So you're saying that people will come in with the public key as identifier in the system. In the system, there's no such thing like a CNN.com, but only whatever the long strings of public key for CNN.
Yeah.
Okay, and it's outside your design how people get that key.
I find this very similar to the net. I mean, you're looking up things in a search engine today, right? So you don't know. I mean, there is a DNS that knows the mapping from the URL to an IP address, right? But then how you get to find what you're looking for, again, it's outside the networking stack. Okay?
It's not finding what you're looking for, but finding the right key for the party you want to talk to. But
So,
I got your answer. You say this is outside your design. That's the answer I'm looking for.
Right, yeah. To the best of my understanding, yeah, you need to be provided the public key or the CD of what you are looking for, yeah.
Okay.
Dirk, I see you unmuted yourself. Do you have a question?
yeah, I think it's just Anthony, I think. So my comment was, so it seems that the binding of real-world identities to the objects in the system, so that's assumed to happen externally. So like CNN.com, for example. So you need a external system to provide that secure binding.
Yeah, so in a sentence, IPFS doesn't provide you with a way to have human readable naming. So you get like these very ugly looking names like QM something something something, which is the CID of the public key. If you want to have something that like users can like memorize, like a CNN.com, Wikipedia.org, whatever, then you need to provide some external system. Well, something external to IPFS to do that linking, to do that binding. So that's correct.
Okay. Yeah. Okay. Great. Thanks.
Yeah. And it's also, I don't know if it relates, but yeah, all you need to get into the system is basically creating a public key, right, as your identity, and then you can be part of the network, if that helps at all. Yeah. Yeah, I would be interested to possibly discuss later or some other time about this. Yeah, because maybe there is something that we need to think a bit more. So okay, so the DHT again, I don't know. I think I should not go into detail, but effectively by being able to jump over the hash space, you can get to if you're looking for node K54, you can jump and get closer to node 54 much faster. And this is done through something called the finger table, where you have you can have, so the finger table for node number 8, given that node number 14 is the next one, is going to point different identifiers between 8 and 14 to that node 14, and this increases here and goes to different nodes. So there you've got different fingers, and that's how you can get to jump faster. As we said before, so the Kademlia is, the main specification, at least from the paper, which is also implemented in the IPFS system, is that the publisher needs to republish the key value pairs that it is holding every 24 hours. So I don't know if this is 2412 or something like that, but it's along those lines. And this obviously, especially given what we discussed in the very beginning about having chunks which are cutting into every file in the world, then this provides a very huge volume of data for every publisher in order to provide to republish the provider records, basically. And that's one of the issues that is being looked at currently, because it's kind of an obstacle. Yeah, so finally, to conclude with the DHT, it's an overlay network, and one of the issues that we're looking at the moment is how we can make it more efficient, in the sense that, a DHT is an overlay, and as an overlay, it's always going to be suboptimal because one node in the overlay can be many nodes in the underlay. Therefore, going towards some model that has been proposed before, which is Coral or similar things, you can build rings or multi-layer DHTs based on latency or based on number of hops or some geographic notion, and build rings based on that. And what you do there is that you're asking first, you're looking in your local DHT or your local ring before you go far away. This assumes, if one assumes that there is going to be some locality of interest of some sort, then this can bring the delay to look up content and fetch content much lower than it is than for a single DHT anyway. So the final part is a very simple protocol called BitSwap, which is actually operating in parallel to the DHT lookup. And what it does is that if you have two users, Easy and Aussie, and each one of them has some CIDs that it wants to fetch, then it's got the want list. We call this, this is called the want list. And it, every node is exchanging those want lists to every other node that it knows in the network, every other node that it is connected to. And there are many connections allowed in IPFS, and therefore, with, you know, apart from the DHT itself, this is another way of trying to get stuff back to, you know, satisfy user requests. So in this case, for example, Easy has got two of the contents that Aussie wants, and therefore returns back this content to each other. So just to summarize, what we have, you know, when we want to publish content, you want to chunk a file, then you obtain the CID, you add the content to the network, which means that the content is not replicated, as we said, but it is just providing provide the record to the network to know that your machine is actually the one that is storing the content. On the consumer side, you need to have the CID, as we just discussed, out of bounds. Then you walk the DHT to resolve the CID to a peer ID, and then you connect and fetch a copy. This copy, once you download it, is stored, is cached locally on your machine. But as David mentioned before, this is one of the basic principles that the system is not going to push content to a peer's machine, and only unless the peer is downloading something, only then it is going to cache it. This obviously helps with popular content, because the more, as the content is becoming more popular, the more there are more copies of that cached around the network. Of course, this is a cache, and at some point it's going to expire unless this user that has downloaded the content wants to add it locally and pin it so that it becomes a provider for this content as well. And as we just said, in parallel, you have the want list that is also looking for want lists around. Now, as it was implied, so again, David, in one of the answers, mentioned that there are some nodes that are called gateways, and what these nodes are doing is that they're enabling users to get connected to the IPFS network through the browser. So the browser cannot really talk the IPFS language, and therefore what it does is that it connects to some gateways that are public. Some of them are operated by Protocol Labs, some of them by Cloudflare. But I guess anyone can operate an IPFS gateway. And what it does is that the gateway is a full DHT server node, and apart from having its own routing table, it can obviously forward further the requests. So there is this extra option of connecting to the network with through a browser without being a full IPFS node. And yeah, I think this is the summary. I hope I tried to put a nice picture around, the blending between all these different protocols: IPFS, IPLD, libp2p, and multi-formats. As you understand, there is much more detail in each one of them that wouldn't fit in a single presentation, and I'm not even aware of all the details. But there is lots of resources. There is very nice documentation there that is talking about all those details and settings of the different parameters. There are some interactive tutorials in this, what is called Proto School, where you can go and do interactive tutorials to get familiar with how things work, how to add things in the IPFS network, and so on and so forth. There is the IPFS companion, which is basically an enhancement to the browser to be able to connect to the IPFS network straight out of the browser, and many more things that you can find in several of those links. Yeah, so there is much more to look out for, especially for the research part of Protocol Labs. There are several different directions that Protocol Labs research is looking into, very radical, not necessarily all of them linked with networks. There are issues going on there on decentralized identity, graph theory, decentralized energy storage. It's pretty cool radical stuff that go beyond what I have talked about. There is ResNetLab, which is it's operating basically. It's a newly founded thing. It's just a few months old, and what it does, the vision of ResNetLab is basically to support the projects, all those different projects that I talked about, but try to look into problems that the projects are going to face a little bit further down the line. So it is there in order to solve problems for the projects when the engineering teams have not hit the wall yet, and therefore provide solutions or specifications for solutions from academia and from all that, in advance of time. There, as part of that, there are several open problems. Some of them we even discussed very briefly, such as the human readable naming. There is an open problem there that is trying to identify whether we can actually have human readable names in a decentralized way, or how can this work? Privacy preserving, content addressable networks, or the scalability of DHTs, things like that. They are also very hot problems that are being investigated, and they're open. We're trying to find solutions and academic literature on that. And yeah, I think this is the final slide and concludes the presentation. So
we have 3 more questions. Maybe answer those and then close. So first question is, are the gateways authenticated?
Authenticated in what way?
Because you see, everyone can provide a gateway. So what if there's someone put the false gateway, then direct the clients to wrong place?
Yeah, I don't know. So any node you can. So one thing that happens is that you can do that as if you're any node, any DHT node. You can. This is something that has to be looked at, and we're looking at right now. Is that you might be able to, you are able to join as a DHT node, but provide false routing information. So to my knowledge, I think they're not authenticated. So there isn't someone that says this is a good gateway node, we trust it. Yeah.
Yeah, that's correct. There is no reputation layer. So like, for example, if Cloudflare decided to go rogue and only serve specific set of content, then we would need like a side channel to communicate that to users, to not use that gateway and use something else. That said, like, because any node, as Yiannis was saying, any node can become a gateway. So you can always like spin a local node in your machine and just verify the results and like test it by yourself. Next question is, when content is cached, how does the DHT or the system know of the existing of this cache, and how and how is it able to use it?
I was able to use it. So when content is cached in some user device, then the provider record for that is advertised from the node, right? So that's how you're becoming a temporary provider for that content that is in the machine. If that runs out of the cache because if that runs out of the cache because you have downloaded other stuff, then you're not going to republish this record in the next, whatever the setting is, 12 or 24 hours, so you're not a provider anymore. If a node wants to become a more permanent provider for this content, then the user would have to explicitly say that I want to add this content, so ping this content, and therefore it's going to stay in the storage locally. And obviously it's going to republish the content, the provider record.
So the cached content is treated the same as the original copy of content. Both of them are published to the entire DHT.
Yeah.
Okay. Thanks.
Next question, and I'm going to jump one, because it's a topic, not a question. The need to keep republishing IPFS records is a single point of failure, that one publisher must remain online and their internet provider must maintain their service. IPFS links are not decentralized, easy to censor. Are you working on a fix?
Right, so this is a good question. I mean, yes and no. So in my view, if someone is a content publisher, then it is in their best interest to be online anyway in order to provide the record. So if you have a company, say, and you have the website of your company, then yes, you have to be online. Yes, you have to have a reliable ISP, and have uptime so that, your customers can reach out to you. So, I mean, what I mean to say is that I don't see it necessarily as a problem. It's basically an incentive that anyone would have if they wanted their content to be alive.
I have an additional, sorry, go ahead and finish.
Yeah, sorry.
But this is different now, because I think this is more, my understanding is IPFS promote like a peer-to-peer networking. That is, I can publish, right? That's supposed to only CNN can publish. If you argue to say, I have to behave like CNN as reliable as well-engineered, that's a little high bar for general publishers.
So, yeah, good point of discussion. I don't know. So, I mean, this has to be seen as a protocol stack, right? So someone could build, a service or a tool or something on top of IPFS that can, provide all those services. So these, the base of what I described, or what is there at the moment, is, the base networking part is not a product in itself. So maybe that was not clear. So this is not a product in itself. So someone should not assume that, this is going to be, something that someone would have to pay for. IPFS is there in order, and it's going to be free. Or you can, replicate it and run a different private DHT, or, a cluster of private nodes. But how, the problem I see with IPNS myself, and I think it's more is widely recognized is that you have to republish a huge amount of data on pretty much a daily basis. So this is something that is looking for a solution, in my view.
I have an additional point to this. So one thing about IPNS, and so specific to the IPNS question about having to republish. So IPNS in itself, like, and this is like over the whole IPFS design, is like very modular. So IPNS is just this idea where you have a record that is signed that points to some immutable record, right? And so we can use the DHT and keep republishing to the DHT to keep the record live. We could use the pub sub channel as I highlighted before, but there are other implementations of this record router, this name router. For example, like very early on IPFS development, someone did an integration with Namecoin. So you could like publish a name to Namecoin and then resolve the name from there. Today, this year, actually last year, Ethereum launched eth.link. And so this is names on the Ethereum network, on the Ethereum chain. And you can also resolve IPNS names through eth.link naming system. And so it really comes down to like having one primitive that like an application could just like rely on like publish record, update record, get the latest record, etc. And then have multiple implementations that give different guarantees to the application level, to the user. If someone is going to be relying on a DHT, they can use the DHT. That's just like public infrastructure. If someone wants something more strict, more with more guarantees, they can just rely on Ethereum.link and therefore count with the liveness of the entire Ethereum network. If they want to provide some other kind of guarantee, they can also do their own implementation. And so it really comes down to like choose your own router, check the guarantees that the router gives to you, and see if they suffice to your application.
I think Dirk asked a great question. I wish to hear
Okay.
That is,
Yep.
is when this runs over IPFS runs over DHT, and DHT requires a substrate to do the forwarding. So therefore, IPFS can only be an overlay over a network of IP-like network. You cannot run over link layer, for example, directly, like IP does.
Over link layer, I don't think so. And unless there is it could be a local network or something.
Yeah, so that is I think it goes back to some discussion we also had at the ICN conference in Macau. So it seems to be that, I mean, although like IPFS supports all these different protocols, it's kind of based on the assumption that well, you identify a peer or ways where to fetch a chunk from, and then you kind of establish some kind of, you know, protocol session, virtual connection, whatever, to that peer, and then you requesting and transmitting the content object. But there's nothing that the network between those peers can really do to assist you.
Mm-hmm.
Is that correct? So you, for example, there's no like in-network caching on any other entities that are between you and the other peer.
Right, that's correct. Yeah, this is correct. So I think that was my understanding, at least, is that this was a design that was made from the beginning, and it provides the flexibility of being able to not be, not rely on, ISP infrastructure, things like that. So the protocols, of course, this comes with the disadvantage that you can only use whatever protocols the ISPs are are operating, and it's difficult to go beyond that. The in-network part that I see is that this is not articulated, it's purely my own opinion that I'm trying to make it a little bit more mature, is that the gateways themselves, they are a very interesting point in the network. Again, at the edge of the network, of course, it's not really in network, but they can provide much more functionality and make the network much faster in terms of efficiency. But yeah, what you're saying is correct. Yeah. However, the important, an interesting thing there is that the fact that the multi-addressing and all the techniques that libp2p is providing make it easy to adopt things very easily. Yeah.
I wasn't sure about adapting things. Currently, the fundamental thing for network does nothing but do forwarding until you reach whatever you need to reach. In the forwarding process, the most important question is who is your next hub? In DHT, this is solved by randomization, not by vicinity of any measure. And therefore, you require an underlying routing network to actually deliver you to your next logical neighbor.
Absolutely, yes, that's correct. Yeah. Yeah. That's, I mean, this goes back to the discussion we had in December on, why there could be, lots of complementarity between ICN approaches that are looking into more native network layer technologies and protocols, and things that would be, implemented in actual network routers, and, a system like IPFS that is operating basically at the edge of the network and could be hugely benefited by something like this, in my view at least.
This is a routing question. I know this is very late, but could I just ask you say a bit about how PubSub works? Is it PubSub by your CID or PubSub by some other identifier?
So the PubSub protocol has got different topics depending on. So in the IPFS there is the topic, the topic entries basically, and so it's not content-based PubSub, it's topic-based PubSub, if that is the question.
Is the topic represented by CID or by a different identifier?
Sorry, who can represent? Sorry?
How you express a topic? Is a topic a CID?
I don't know this detail, but I think I don't know this. I don't think so. I don't think so.
Okay.
I don't think so.
Thank you.
And then there is several different mechanics in this specific PubSub protocol, but I'm sure you're not asking about that yet. But yeah, the forwarding on your previous question is it does not.
So there's any documentation on the PubSub side?
I can, yes, there is both in, I can send you some pointers. Yeah, there is in the documentation, there is a technical report.
Mm-hmm. Yeah, that'd be great.
Yeah.
At the beginning of the talk, you mentioned Web 3.0 is to move trust to the network. What does that mean? And how is this reflected in IPFS?
Right, so there is this bigger kind of wider Web3 movement that intends to provide some decentralization of internet services. That could be from storage, it could be from computation, it could be from several different parts, from decentralized identity. There are several different ways that people are looking into the space of decentralization, but effectively all of it is going around the fact that, the well-known fact that I'm sure we've discussed before, the fact that, there are some tech giants that have way too much power than what they should have, than what people want them to have, and also than what the internet was supposed to give to any single company or operator in the world. So the Web3 movement is describing. I mean, okay, yeah, there is some definition of that where, there was the Web 1 where there were only static web pages. That was during the 90s or whatever. Then in Web 2, which is what we have now, you have lots of interactive content, interactive applications, from what we do right now to interactive websites and gaming and things like that. But all of those, especially with social media applications, but not only, they have given superpowers to some companies. And people now are trying to figure out ways where, the protocols could still run. The protocols could, we could have the same experience as we have today, but without having, Dropbox as the main storage solution, or without having Amazon as the main computing solution, or without having, all identifiers based on Facebook or Twitter in a central database. I even forgot the question. Did I answer anything, Lan? Or?
I was talking about the trust issue.
Right. Okay. So
how do you trust that piece of content is supposed to be published by that key or some key?
Right. So what you can do with having the content addressable part is that, you can have, basically, you can verify that what you're receiving is what you asked for, and therefore that no one has tampered with this data. Now there is lots more to be added to that, because for example, who you're giving access to is another issue that is not part of the IPFS stack at the moment, as far as I know. But it could be something that could be built on top or in parallel to that. And of course, the fact that anyone can join the network with a peer ID and publish, and it's not. So IPFS is not operated by Protocol Labs, for example. So it kind of goes with this mentality of not being subject to the decisions of one single entity.
Is it possible for me to just publish CNN/news something?
Yeah, it is. Yeah.
But there is some external other ways to verify that I'm the authentic publisher.
So if I download the content that you have published and you have signed with your private key, then I should be able to verify that this is what I got because I have your public key. And this is coming from you. Now, whether your public key goes with your name and physical identity, that's a different story.
Actually, there's like a very interesting development that happened last year. So, again, like let's just recenter us. So the starting point was HTTP. You like shared at cnn.com/some document.pdf, right? And like now you have to trust the central point of authority that like you are actually receiving the right document. With IPFS, you transition into like a like hash linked world where now you can verify that the bits that you received are the correct ones. So you can authenticate content. But last year, thanks to the HEMP project from Google, and the fact that Google was facing some challenges in terms of being able to distribute signed content to browsers and for browsers to be able to verify that the content came from the original publishers and not from Google. So this was like a problem on HTTPS layer. We actually got IPFS to become distributed of web packages. And so a web package is just like a website that has been hashed, signed, and certified that it can be distributed through some other gateways, through some other endpoints, without requiring it to be served from the original domain name. And so I will link here on chat, but it's basically a talk that does the demo of like publishing a website that could be CNN.com, could be whatever you want, signing it, and then putting it on the IPFS network, and then having your browser like checking that signature, verifying that it's the right signature from the right publisher, and like verifying that like you actually are reading a thing that was published by CNN.com and not from Yiannis, right? So that gives you like even an additional layer of trust where not only you are verifying the bits that you receive, now you can verify that the bits that you receive were actually signed by the original publisher, although you don't even need to talk with the original publisher to do this verification. And this is all integrated on the browser, right? So this is not like an additional extension that users need to install. It's not an additional step that users need to do on the command line. This is just like all in Chrome. Yeah, I'm just looking for the link and I'll post it here. I think you will find it interesting.
Okay, thank you.
Okay, so I think that it's very great talk, and probably people have more questions, but we're already running out of time. It's 1 hour and 30 minutes. So Yiannis, if we have more questions, what's the best way to?
Right, I forgot to put my email in the last slide, but you guys know that I can send something, contact details, and you can forward to the list, so I can forward to the NDN lists, those that I know. My email address is this one in the chat. So yeah, please feel free. I can make the slides available if you want. That's no problem with more resources. Yeah, I think over email is the best.
Okay, sounds great. Yeah, really thank you and your team spending time, and it's a great learning experience, and I think very interesting system. And on our side, we are thinking how NDN network or architectural technology can help IPFS as application to be more scalable and more efficient. So we need to spend time to think and discuss about this, and maybe later also exchange with you guys.
Yeah, exactly. Yes. Thanks a lot for the time. Thanks for the very interesting questions. I'm very much interested in knowing your thoughts about that. Yeah, we have said many times that there could be some opportunities for collaboration there to make the whole stack basically much more efficient and yeah, be of benefit to everyone actually. So that's great, Bertrand. Thanks a lot.
Yeah, thank you guys.